So now that we know how to create and generally use pointers, how we can dereference them, let's see how we can work with pointers in conjunction with functions. And for that here, in getAdultYears, we could say that we don't want to get an int value itself, but instead a pointer to an int value. Therefore, we should change the type of parameter we're expecting, because we don't want an int, but instead a pointer to an int, which means we have to add an asterisk here. Because that was the same type we used here for creating such a pointer. So with that, we get a pointer instead of an int, and therefore here I'm getting an error. That I can't perform this operation if one type is a pointer essentially, because in Go, unlike in some other programming languages, you can't perform pointer arithmetic. You can't perform calculations on pointers. In some languages you can, and you can run into really nasty problems there, but it can also be a powerful feature. In Go you can't. You can't deduct values from a pointer, so from an address or anything like that. Instead here, if you want to perform this operation we are performing here, we have to dereference the pointer. We have to add this asterisk. So with that, we're getting the address, then we're looking up the value that's stored under that address, and we're deducting 18 from that. And then, just as before, we return that new value. So therefore, we can still create AdultYears and call getAdultYears, but now here, we should not pass age as a value to getAdultYears, but instead a pointer to age. Which we could again create by using this ampersand operator here, or, since we already have an age pointer, by using that and passing that to getAdultYears. With that, we want a pointer and we get a pointer. And we should therefore get new AdultYears, and we should be able to output them. So with that, we can run this again, and we get the same output as before, but now with pointers. And the difference, the important difference now is that now there's no copy of 32 being created. Instead, we create it once, and it gets stored in memory once. Then we create a pointer, so we get the address, but we don't copy the value or anything like that. And we then pass that pointer to that function where we want a pointer, and therefore again, nothing is copied. It's still the one single 32 value. And we use that same original value here in this calculation. Though I also want to be very clear, avoiding a copy of an integer value will not be worth it. Because this number is a super small value in memory. So copying it and having all that extra work with creating the pointer and so on is not worth it. It's just an example to show you how this generally works. You should not start avoiding passing integers to functions and replace them with pointers. You should not do that.